Hello everyone, I'm Jingsun from Weizhiyu Technology. Now I'll introduce our work on policy gradient applied to Mahjong. Okay, this is the outline. First, I'll introduce the background and the main idea of our work. Then we'll go into the details of the project, from data processing to the models we used, which are supervised learning method and reinforcement learning method. After that, the results of our experiments will be showed, and finally, the conclusion and future works will be given. As we all know, in recent years, reinforcement learning method is widely used in developing gaming AI and gained spectacular achievements, such like AlphaZero, StarCraft 2, and Suffix. As for our project, the research target is Chinese Standard Mahjong, a 4-player imperfect information game, which raises a challenge that there are large amounts of hidden information during the game process. In our work, we solve this challenge by using reinforcement learning methods together with adding more information to the model's input, which proved to be a useful way to improve the performance of Mahjong AI. Actually, we did much work on exploring an optimal input structure to the neural networks. A series of features are extracted from human game records, such like the cards a player holds and the cards the 4 players had discarded, and in addition, we calculated some extra information from the record. For example, the information indicating if a player currently is in team state, and so on. Then these information are mapped to a matrix according to one-hot encoding. Then the basic unit of the input is a vector with 34 dimensions. Each dimension stands for a type of card, just as shown in this figure. Finally, notice that we make the 34 as the channel dimension, which got better performance compared to a single channel. Okay, now I'll go into the model architecture. The model we used is a basic CNN architecture. Each CNN operation followed by a batch normalization taken as a layer, and every 3 or 5 such layers together with a residual connection make up a block. The blocks then are stacked to form our final model. The details of a block is shown in this figure. We developed 3 models for discard, pong, and chew operations, respectively. They share the same architecture. The only difference is the output norm. For discard model, there are 34 outputs, represent the discard probability of each card, while for pong and chew models, there are only 2 outputs, indicating whether to do the operation. After much work on supervised learning method, we found it hard to further improve the performance of the discard model, while pong and chew models have actually achieved satisfied performance. Therefore, we turned to reinforcement learning in order to get a better discard model. Policy gradient is a specific algorithm of RL. The core idea behind is to maximize the expectation of an accumulated reward of trajectories, which generated by the interaction between the agent and the environment, say R of theta. And here are the mathematical formulas of policy gradient. A critical factor in reinforcement learning task is how to design a reward which is given by the environment to the agent. We actually tried several methods and finally found an effective one. Here, we define the win distance as the number of cards still left to reach a winning hand, and the reward from the environment is given just according to the win distance. Here is an example. Suppose we have got these cards in our hand, and the nearest winning hand is like the following one. So we can find that We only need to replace the east by west and the south by north. Then we can get a wind hand. So here the wind distance is 2. For the reward, we make rules that when an agent discards a card, if the wind distance increases, that means it gets even far away from a wind hand, so a negative reward is given. Well, if the wind distance decreases, which means it gets closer to a wind hand, so a positive reward will be given. And if the wind distance just keeps the same, 0 will be given. Okay, here is our experiment results for supervised learning. The dataset size and we use is as the table shows. Notice that we use 90% of each dataset for training and 10% for testing. The accuracy of our 3 models is as shows here. As you can see, the Peng and Chu model have got very high accuracy, both over 90%, while for the discard model, the accuracy is relatively lower, just over 70%, and that's why we turn to RL later. For the discard RL model, we trained it starting from the supervised trained model, which saved lots of training resources. This figure shows the winning probability of RL models over its baseline in real game test as RL training steps going on. As we can see, the win rate of RL generated model is increasing as training going on, which means the RL training does help to improve the performance. Note that the RL AI and baseline AI share the same Peng and Chu models, while the discard model is different. To sum up, in this paper, we proposed a reinforcement learning method for designing a Chinese standard Mahjong AI. The training process mainly includes 2 stages, the supervised training stage and the reinforcement training stage. Learning blindly from reinforcement learning is feasible, but could cost a lot of resources and time. However, using human data to train a supervised model and then tuning the parameters by reinforcement learning could save lots of time, and the results show that this 2-stage method could get good performance. Also, there are many aspects to improve in this project. We used policy gradient, which is a very basic reinforcement learning method. Further improved IR methods such like actor critic, advantage actor critic may get better performance, and we will try these algorithms in our future work. And here are the references we mentioned before. Thanks for your listening.